The story of climate change science stretches back much further than many realize. While it may seem like a recent topic, scientists have been piecing together our understanding of Earth's climate for over 200 years. Our tale begins in the early 1800s with a French physicist named Joseph Fourier. Fourier was puzzled by a simple question. Why was Earth warmer than it should be, based on its distance from the sun? He hypothesized that the atmosphere must trap heat somehow, like a blanket. This was the first inklings of what we now call the greenhouse effect. A few decades later, in 1856, an American scientist named Eunice Newton Foote made a groundbreaking discovery. Through clever experiments, she found that carbon dioxide trapped heat more effectively than other gases. Foote even speculated that changes in atmospheric CO2 could affect Earth's temperature. Sadly, her work was largely overlooked at the time. It wasn't until the 1890s that the pieces really started coming together. Swedish chemist Svante Arrhenius wondered what would happen if CO2 levels in the atmosphere changed significantly. After painstaking calculations, he concluded that doubling CO2 could warm the Earth by 5 to 6 degrees C. But could human activities actually change atmospheric CO2 levels? In the early 1900s, scientists began considering this possibility as coal use skyrocketed during the Industrial Revolution. By 1938, engineer Guy Callenderer estimated that human CO2 emissions had already warmed the planet by 1/3 of a degree C. Still, many remained skeptical. The oceans, they argued, would simply absorb any excess CO2. It took the work of oceanographers like Roger Rell in the 1950s to show this wasn't the case. The oceans couldn't absorb CO2 as quickly as once thought. To settle the debate, we needed hard data on atmospheric CO2 levels. Enter Charles David Keeling, who began precisely measuring CO2 in 1958 at Mauna Loa, Hawaii. His measurements revealed a clear upward trend in CO2 concentrations, now known as the famous Keeling curve. By the 1970s, evidence was mounting that the Earth was indeed warming. While some pointed to localized cooling in parts of the northern hemisphere, global data showed an unmistakable warming trend. In 1980, NASA scientist James Hansen predicted significant human-caused warming would be obvious by the year 2000. As we entered the 1980s, the scientific consensus was clear. Human activities were increasing atmospheric CO2, and this was warming the planet. The foundations of modern climate science were firmly in place. Built on over 150 years of research and discovery, the story of climate change science is one of gradual realization, with each generation of scientists building on the work of those before. It's a testament to the power of the scientific method in uncovering the workings of our planet, even when the consequences of our discoveries are profound and far-reaching.